Hey Babs, how's everyone doing? Hi Ro, how are you? I'm doing good. I got some food. And I'm feeling good. Let me turn my chat box off. But yeah, how are you doing? Hydrate, will do. I just got a bun, that's literally all I have. I'm probably just gonna be snacking throughout watching the videos. So hi Annie, how are you? I don't know, do I feel lo-fi today or do I feel upbeat? I feel upbeat today. Let's actually start with Gravy's new release, because Gravy released this, I think yesterday, and I love it. So huge thanks to Gravy for letting me use their music. That's a lie. I am not. I am the most shy person at a party you will ever meet. No, you're not updating. Come on. Why are you not updating? Just being stupid. There it is. Gotta give it a push. Alright, then. Upbeat it is today. Yeah, I did complete the tutorial checkpoint, which actually I can show you the result of the last section. I think I did the quiz on stream, but I didn't do the cube. So, we made, or I made this cube as part of the finish assignment. So pressing space moves it around the screen at a random position. Hitting S changes its size. And holding down F causes chaos. It is perfect in every way. So yeah. The cube. Yes. Also, can I just say that for how simple that is, how much code this required? Like, that is just for that goddamn cube. This is just for the fucking cube. But yes, the chaos button. I love it. Alright, missions. I also have a ping. You found a joyful image on the interwebs? Please share. I am curious. I'm gonna post on Discord. Yes. Perfect. Gonna head on to your job. Okay, Rose, stay safe. Bye. I love it. That is perfect, though. Okay, so this is actually 3 projects instead of 2, so this is gonna be fun and take a lot of time. Yeah, this whole thing will take approximately 25 hours. Probably longer, because I'm gonna be only working on it for like 3 hours at a time or something. But, create custom interactions with Unity, complete 4 practical projects, concepts, support basic functionality, including loops, data types, references, script communication, and UI. Just scrolling through Tumblr. Fair. Yeah. Ooh, we actually get to make UI. I like it. So, and then... well, let's get started. I don't think I have it enabled for my music to auto-pause. Give me 1 moment. Oh. Because then I don't have to pause manually.
You know, if you take the word Unity and add an R sound, you get Unit Tree, which kind of sounds like Unit 3. It's a pretty amazing coincidence because we are about to start Unit 3. In this unit, we will create a beautiful, fast-paced, endless side-scrolling game.
Can I just say that I fucking hate that joke? God damn. That was terrible. Alright, continuing with the instructions.
Where the player needs to jump over obstacles in their path. Now, as you were watching and listening to that, you probably noticed that it felt a lot more polished than either of our previous prototypes. That's because it had animation, sound, and particle effects. Did you see the character running, jumping, and dramatically falling over? Did you hear the sound effects and music in the background? Did you see the little particle effects kicking up from the back of the character's feet and the massive explosion at the end? It's these little touches that will take your good project and make it great. These elements help immerse the player in the environment you've created. Being able to add them to your projects will be a literal game changer. So let's start creating.
All right. We'll get to play with Unity's particle system, the system that you use in Unity to create particles. I can't fucking get over that joke. Goal of this lesson is to set a basic gameplay for the prototype. Let me, hold on.
Then we make some particles using Unity's particle system. And to make this laser, I use Unity's particle system. Then I did a thing using, of course, Unity's particle system, which means you can add some particles using Unity's particle system. And milk drinking simulator is explosive, so I made an explosion effect using Unity's particle system. Did some programming, and let's test it out. Big smoke. So I made some smoke with the Unity particle system and put it into the game in there, and also made some bullet explosion using Unity's particle. And here you can see
it's just a fucking meme. I love it. Alright, I'm gonna need those. So, let's see.
As usual, since we're starting a brand new prototype, the first thing we'll do is make some creative decisions. The basic premise here is that a character is running and jumping over things. But will it be a farmer jumping over crates in the wilderness, a construction worker jumping over barrels in a quaint town, a guy in a suit jumping over giant spools in a big city? These are decisions that only you can make. But after you've done that, we've got a lot of programming to do. Because by the end of this lesson, you will be able to press spacebar to jump over obstacles as they fly towards your character at high speeds. Now we've moved objects around before, we've moved a vehicle left and right, we've made animals and food fly across the screen, but we use the translate method to do all of those things. And the translate method essentially drags the object through the scene at a particular speed, regardless of any laws of physics or how heavy it is. The way we're going to make this character jump is completely different. In order to get that smooth, realistic looking falling motion, we'll have to rely on Unity's physics engine, which takes into account the mass of an object, any forces acting on it, and gravity itself. So instead of translating this character up and down, we'll call the add force method to apply a single upward force on the character's mass, and then sit back and let the simulated force of gravity do its thing. So to make all that happen, I'll see you in Unity.
Okay, I like it.
Alright, so let's get started with prototype 3. Now I'm going to import the project files and set up my new Unity project, but since we've already done that, let me just open up Unity so that we can get going. Now I'm going to go into the scenes folder underneath my project window, open up prototype 3 by double clicking on it.
My server's blocking messages? Huh? I don't see any messages being blocked. Where is it? There, unlock. For fuck's sake, fuck off. Yeah, there's nothing in the log either. That's the Discord bot itself. Works now. That is great though. What message does the Discord thingy give you when it blocks the message? Why? Why can I not adjust this? Patty, DM me the picture. Why the fuck? It shouldn't. I love it though, that's cool. I like it. It is adorable. Yeah, it's for some reason the auto mod setting is stuck to the actually I can just show you. I literally cannot change the auto mod setting any lower. And I don't understand why, because it used to be on disabled. I used to have it on disabled. So I don't understand why it's being this way. I might just have to let's see. I might have to make a Discord ticket. Yeah, I can post it. Yeah, I don't know. I'll have to maybe make a Discord ticket and see about that. Was there... Did I miss a changelog? Not that I can see. Well, that's stupid. It's fine. I'll just have to make a Discord ticket later. Discord, why are you being this way? Alright, continuing.
I'm going to delete my sample scene by right-clicking on it. Delete. Let me reposition my camera here. Oh, I'm on the other side. Okay, cool. So that looks like what's in our game view. And then last but not least, once I've had all of my assets imported, you can actually select the background object in the scene. On the right side, you'll see in the inspector for the background, this sprite renderer. Now a sprite renderer is a component that enables you to render or to see images in your game and in your environment. So in this case, we have this background image. So we use our sprite renderer to actually see that image in our scene. Especially when you're making 2D games, sprite renderers are particularly useful. If you have a character with items or they're carrying something. So with our sprite renderer, on the right, there's a little property called sprite. And you can see currently it's set to background town. All the way on the right side of the inspector, there's this little circle icon. It's a radio button, so you can actually click on it. And there are all these different options. So there's in fact actually 3 different backgrounds we can use. So you can select one that works for you best. I kind of like this forest scene. It's very natural. It's got a lot of bright colors on it. So now I can just close out of this window and we have a background selected. All right, so what you're gonna do is open up the Unity Hub and create a new Prototype 3 project. Use the link below in the steps to download the project starter files. Make sure to open the Prototype 3 scene and delete the sample scene. And then you can select the background object in the hierarchy, and then in the sprite renderer component, you can go to sprite and select a new background image to use if you want to use the city, nature, or town background. So now it's your turn.
Right. Well, conveniently, I have already made the scene before I started stream because I figured we need one. Import package. I didn't unzip the file yet. Extract all. Boop. Yep. Right, switch to this one, delete this one. Yep. Alright. Then I would like... Yeah, I like the nature one. Saw that. Oh, I didn't... I forgot to put streamer mode back on. George Bush was informed that Brazilian people were killed in Iraq when he was... Beautiful. Show into positive affirmation. Let me fix that. I don't know if that fits into positive affirmation. I don't think it does. Fair enough. Okay. I am also not on my layout. There we go. When there's something that fits to you, you'll need to look a lot. That's fair. Alright. Done. Next.
Cool, so we've chosen a background for a project, so we're good to get started. Now we need to give the scene a little bit of life, so we're going to add a character for the player to control. So in our course library, we have our characters, and we have the choice between farm or town, so I'm just going to go with farm characters, and we'll just, I think that one looks good. So we're just going to drag that into our hierarchy. Cool, so now what we're going to do is we're going to rename this to our player, just like we did with some of our other players. And our farmer is kind of facing towards the back, and that's not what we want to do at all. So if we just turn the farmer, let's just say like 90 degrees, so now it looks like the farmer's facing forward. Cool. Perfect. Awesome. Now, one of the things that I'm going to do just because I know I'm going to need these later is I'm actually just going to add a rigid body component now. And then I'm also going to add a box collider. And let's see where that box collider is. It's very small. It's on the character's feet, which is definitely not where we want that to be. So let's bring that up to about the center. And then we'll make that a little bit larger. We'll make the Z a bit larger, and then we'll just make sure that the Y is properly set up. Cool. Looks just about right. Okay, awesome. So now that we have our box collider set up on our player, one of the things that we're going to do is create another scripts folder by right-clicking on Assets. And we're going to need a player controller script to actually move our player. And then we'll just make sure that we attach our player controller script to our player. Click on the player and make sure it's there. Perfect. So now what you're going to do is you're going to select your own character and add them to the scene through the hierarchy. That way they're at 0, 0, 0. You're going to rotate your character on the Y-axis, so then that way they're facing in the direction that we want them to. Make sure you rename your player character, add a rigid body to the player, and we're going to keep gravity on. Add a box collider and just make sure that the box collider fits within the character. And then you're going to make a scripts folder in Assets and create your own player controller script. So, now it's your turn.
Right. Let's see. Let me move you over here. Same as you. So everything I need is on there. Hi, Nags! How are you? What do we take? Let's go with you. Boop, boop. Just so I stop clicking on it, because I will keep clicking on it and it will drive me crazy. In sad boy hours? Aw, why is that? Did something happen? The hat does not necessarily need to be in the collision box. It's whatever the body is colliding with mostly. Okay. Just a bad day. That's fair. Here if you need anything. Did I forget something? Oh yeah, scripts. And we need a player controller. Blab. I didn't mark the other steps complete. No, I did. Alright, next one.
Cool, so we have our player set up as much as possible for now. So in the past, we've commonly gotten just the game object or the transform component whenever we wanted to call any methods. But if we want to actually control the movement and the gravity of the player and all of that, we actually need to use a new way to get a component for our rigid body, because rigid bodies aren't something that are automatically on other game objects versus something like a transform, which is always on game objects. So we'll do that using our player controllers.
That's okay, Nogs. If you need to lurk all you want, as long as you can find some comfort here, that is perfectly fine by me. So I hope you feel better soon.
Script. So in our player controller script, we're going to create a new variable. I already know that I don't need this to be seen by anything outside of this class, so I'm going to name this private for now. And then it's actually going to be our rigid body. So this will be the rigid body component on our player, similar to how we had attached game objects before, but in this case, this is a rigid body. And we're going to just name this player RB for player rigid body. Now, versus something like transform, where we can already get access to our transform component, we don't automatically get access to our rigid body component because that's not something on every single game object. So in order to do that, we actually need to use something called getComponent. So if we take our player RB variable for a rigid body, and now if we assign that or set that to the component of our rigid body, so we use a method called getComponent. Now we have to use these left and right carets here, which is different than using parentheses to pass in parameters. Specifically, the left and right carets actually get you a type of something. So for example, in this case, we're getting a rigid body, but you could use these carets to find the type of anything. So if we actually want to get a collider, for example, that was on our player, we could do that too. So the carets are specifically for finding different things like our components that are on our different objects. Now we do need to close this with a parentheses because it is actually a call that we're making as a method. And we'll close that statement. And then just to test and see if this works, if we actually got that rigid body, we're going to apply a force to our rigid body. Now, because we're using a rigid body component, it already has a method called addForce. And you can think of this similar as transform.translate, but instead of moving something physically just using positions, we can apply forces to things just like we would in the real world using physics to make something move. So in this case, we're going to make our player move up just to see what happens. So we're going to use vector3 dot up, and we're going to amplify this by a lot, so we'll just multiply this by 100, and then we'll save. And now in Unity, if you look at our game view, when I press play, the character jumped very slightly. Let's see if we can make that a little bit more powerful. Let's set this to something like 1000. And we'll save. And now back in Unity, we'll press play. There you go. That's a lot of force. And then because he has gravity, the character falls all the way back down to the ground. We'll do that one more time.
It's like he's so excited. Cool.
Not quite into space and beyond.
So what you're going to do is going into your player controller script. In your player controller script, you're going to make a private rigid body variable called player RB for the player rigid body. And then in your start method, you're going to assign that rigid body to our rigid body component using the getComponent method so that it can find the rigid body on the player. And then we're going to apply a force to that player so that we can see that they're actually jumping in the
Oh, we're coming back down. To space and beyond. This is always one of my favorite things about this. And there we go. It could not have been any more perfect. Alright, let's try 500. Let's see how high that goes. That's actually not bad. That is actually not bad. No! Nobody's getting high. Yeah, 500 is actually not bad. So we'll leave it at that. No! Bad! Both of you! Bad. Yes, it is, but bad. Hey, next one.
Cool, so we're making some good progress. We've added the rigid body to the player so we can use forces. So when we press play, our player flies all the way into the air and then drops all the way back down. Now we're going to make it so we can use input from the player to actually control this jump. So if we go back into our player controller script, we're going to go into our update method and we're going to use an...
Weed is legal. Well, actually, I don't think it is here, but at least in the States, weed is legal. No, I said he was gonna smoke it, just buying it for later. Well, regardless. Just bad. Regardless, it is bad. It is the same as alcohol. Bad. So don't.
An if statement. And in that if statement, we're going to check whenever the player presses the space bar. So using our input manager, we're going to get the key down. So when they press that key down, and the key that we actually want is going to be our space bar. So we're going to get the key code for that. And then I think it's just called space. There you go. And then inside of our if statement, now what we're actually going to do is we're just going to take our add force, cut it out of start, so that way the player doesn't just jump when it starts, although we could do that because that'd be fun. And in our if statement, we'll make it so that the player jumps whenever we press space. Now, one slight change that we can make to this to make it a lot more immediate when the player jumps,
I saw that. Thank you.
is by actually changing our add force method just a little bit. So we're going to drop this back down to 100, we'll say maybe 10 for now. So you can see when we were originally passing in this parameter, we were just passing in a vector 3. But you can see when we added this comma that we can actually add in a force mode. And so we can actually apply different forces through this force mode. So, in fact, if we actually type in, oh, it auto completes force mode for us, which is pretty nice. So we'll just type force mode. And then we're actually going to apply an impulse force. Now there's 4 different kinds of forces that you can apply. There's a normal force mode, which applies that force over time. In this case, force mode impulse immediately applies the force that we want to apply. So in this case, you should see that player jump happen a little bit faster. So if we go back into Unity, if we go to our player and we focus on them, and then we play our game. Now, when we press space, you can see that the player jumps almost immediately, and we, in fact, actually need less force because we're not trying to apply a force over time, we're just applying that force right now, so immediately they get to 10. So, what you're going to do is you're going to add in your own if statement to get the spacebar input, and then you're going to move that add force method from start down into our update method inside the if statement, and you're going to change the parameters that you're putting in so that it's a vector 3 up times 10, and you're applying the force mode as an impulse. Now it's your turn.
Making Mario? Well, I suppose. It's more like an infinite runner. I am looking at chat when I'm watching a video, Fox. I'm not busy doing anything, so I can see chat. It is your own fault. Oh, And let's set this to 10. Input, get key down. Key code space. Well, I feel like Ghosty's in trouble now. Force mode. Impulse. Oh, wait. Uh-oh. I don't regret it. I forgot to make this a public variable. Yeet! Yay! Oh. Okay, well, we'll never see that character again. If she weren't allergic to THC. What is THC? Hey, next one.
Cool, so we can make the player jump. You look so happy. I'd be jumping for joy right now. So what we're gonna do is, in our code, so you can see when the player jumps, we have this 10, which is a hard-coded value. We don't like that. So we're gonna change this to a variable in case we wanna change the amount of force we want to apply going up. So we'll make this public so we can see it and mess around with it. It's gonna be a float. And then we're just gonna call this jump force because it'll be the force of our jump. And we will set this to 10 for now, so that way we can hold it. We're going to remove the 10 and call this jump force. Perfect. Now, one more thing that we're gonna do is in our start method, one of the cool things that we can do is actually change the gravity of our physics. So what we can do is we can call physics. So this will actually get all of the physics in our game in Unity. And we can actually get gravity.
I spaced out for a second. I just noticed I actually predicted the variable already. He called it the same way. I called that a win in my book.
By typing dot gravity. So it's a property of our physics. And then we can type in star equals. So if we hold shift on 8, it'll make that star. So that means multiply equals. And then if we type in something like our gravity modifier, so this will be a variable that we'll set later. So we have this weird statement right here, and we've definitely seen a lot of interesting symbols, and this one is definitely a new one. So this is actually a shorter-hand way of saying physics dot gravity equals physics dot gravity times gravity modifier.
Oh.
So instead of saying this twice, which could both be really confusing and is redundant, we can actually just short form this by saying times equals. So this will be physics.gravity equals physics.gravity times gravity modifier. So we'll get rid of that statement because we don't need it. And we'll go into our variables and we'll set gravity modifier, so it'll be public so we can mess around with the gravity. This will be a float as well. And then we'll use gravity modifier. Cool. Now, when we go back into Unity, so you can see in our player, on our player controller script, we have the jump force and the gravity modifier. So when we press play, if we press space, our player jumps and they're still going. They're never coming down, just forever and ever into the distance. Maybe he might make it to space one day. So actually, because we multiplied our physics gravity by 0, there's actually no gravity at all. What we actually want to do is if we stop playing, and we'll bring our focus back on the player. And we don't want that view, so let's, there you go, reorient the camera. So if we actually want real physics, we'll set this to 1. So this will actually set it so that the gravity is what gravity normally would be. And now when we press space, the player should jump exactly as they did before. Cool. Now they're jumping a little slow and it looks kind of weird, so we'll actually, let's set this to like 1.5. And then we press space. There you go. It looks a little bit better. Maybe if we set this to like 2 and the jump force, and their player fell over. Let's see if we set the gravity to twice as much, and then we set this to like 15, and now we jump, and there's still a lot. But our player looks really happy, so, you know, can't complain about that. So now what you're going to do in your player controller script, you're going to add a jump force variable so we can get rid of this hard-coded number right here. Down in our update method, you're going to make a gravity modifier variable so that you can set the gravity to be whatever you want it to be. And then in your start method, you're actually going to set the gravity of our physics system and multiply it by our gravity modifier so that we can change how much or little gravity there is in our game. So, now it's your turn.
All right. So, I have done the jump force already because I was ahead on that. And then we need a public float for gravity modifier. Looks wrong. Yeah, it's I. I'm gonna set that as 1. Just by default. Then physics gravity equals gravity modifier. Okay. Right. Right. Cool. Now, same as before, I'm going to set this to 5. That didn't do anything.
doing fine right now, but we both know that it's wrong. I wish I could be better, oh, get us where we belong. She said we're doing fine right now, but we both know that it's wrong. And we keep spinning round and around just like the same old song. Well, we don't wanna press rewind, don't wanna waste our time, just wanna be alright. We don't wanna waste our time, just wanna be alright.
Yeah, I can kind of agree with this. It would be easy to just change the mass of the force. Well, if you would want it to go faster down, you would just change the mass. But why is this not working? I am confused.
I wish I could be better, oh, get us where we belong.
I am confused. If I set this to 0, you should not be falling anymore. Hi, game man. How are you? Even misspell words that aren't real. Dyslexia at its finest. Yeah, physics.gravity times equals gravity modifier. Physics.gravity times equals gravity modifier. Why are you not working? What if I do this the long way? Will you work now? So if I set this to 0 before we start. Now it works. Oh, wait. I know the issue. It does work. Because in the start method, it doesn't continuously update. That's the issue. It only updates the gravity once when it's run. Just chilling before your shift. Ah, nice. It is working. But start only runs once at the beginning of each thingy. That's why. I actually kind of like that motion. I just need to have that go higher. So actually, let's set this to 4 and this to 40. Nope, too high. 30? Nope, too high. 20. I like that. Stop falling. Okay, let me, hold on. First of all, we're fixing that. Stop turning, stop falling. Right. Add this to what, 20? I quite like that. We can fly! I like this. This seems nice. Yeet! And into space! Goodbye! We have transcended all boundaries of gravity. Oh nope, nope, we're coming down like a rock. We're coming down like a rock. Whoops! Can we salvage it? I'm spamming space as much as I can. I think we lost it. Oh no, we're coming back! We're coming back! We're coming back up! Come on, break through the ground! Nope. I said break through the ground! Why can you fall through but not get through again? Come on! I know you can! Well, at the very least. Aha! I win! Alright, where were we? Next!
So, we've made it so that our player can jump in the scene and they look so excited.
I hate how right you are! That is honestly... honestly, that's probably why I'm considering to have like ground or like wall textures instead of being like just that thin plane, have them be like actually some thickness so you can't just walk through them or fall through them. But yeah, you have a point. It's not far from AAA games quality.
Look at them go. But a funny little thing that you can do is because we're just looking for whenever the spacebar is down, the character just goes up. In fact, if we just keep pressing spacebar, our player will just fly off into space. Very fitting. And then eventually they'll come down. But I think we've actually applied too much force. So, we need to actually fix that, and we'll have to use some of our coding skills to do so. So, in our player controller, we're going to create a new variable. And this one will be public so we can see what it does. And we're going to use something called a bool, which is short for Boolean.
I was trying to mess with that before.
But for now, we'll call it is on ground so that we know the player is on the ground. And we're going to set this equal to true. Now, a Boolean
I couldn't get this to work when I was trying to make this.
Another kind of data type, just like an integer is for whole numbers, floats are for decimals. A bool is simply a value that holds true or false. This is particularly useful whenever we have our conditional statements that are trying to check if something is true. So what we can do is, in our if statement, we can actually add some code in here. So, for example, when the spacebar is down, this condition is true, and it'll add the player force to make the player jump. We can use two ampersand symbols, which if you hold shift and press 7 twice, this means and then if we type is on ground, so this means that whenever the player is on the ground and whenever they press the spacebar, we'll then apply that force to make them jump instead of letting them be able to fly off into space. One more thing that we're going to add in our if statement is when the player jumps, we're going to set is on ground to false. So now in our update function, we'll know that when the player jumps, they're no longer on the ground. And so therefore, because is on ground is false, this entire statement will not be true. And so it won't let you actually jump again. The only downside is that we never actually set is on ground back to true. So we're actually going to use our collisions again. So since we have a collider on the player and we have colliders on the ground, we know that when the player touches the ground, that they've entered the collider box for the ground. So if we type private void on collision enter, and conveniently Visual Studio auto completes for me the entire method, so I don't have to write all of that out myself. So whenever the player enters a collision with something, now we can set our is on ground to true.
I'm going to pretend I didn't see that.
Now if we save this and we go back to Unity, and in our scene view we'll bring our focus back to the player and we'll get a better angle. There you go. So we can watch this is on ground variable down here, this boolean, and right now since it's true, it's checked off. We know we're on the ground. And when we press space, is on ground is unchecked. When we land back on the ground, is on ground is checked. So it's another good reason to jump for joy. Cool. So now what you're going to do is you're going to create your own boolean variable called is on ground, and we're going to set that to true. In our if statement, you're going to use two ampersand symbols. Remember, hold Shift and 7, and then you're going to add is on ground, so that way it's another statement that also has to be true within this if statement. When the player jumps, you're going to set is on ground to false. And then using our colliders, we know when the player's on the ground and when they're not. So you're going to use the on collision enter method, and then you're going to set is on ground back to true when the player collides with the ground. Now it's your turn.
The only thing I will say to this, and I'm going to say this once. Music, shut the fuck up. The only thing I'm going to say to this, and I'm saying this once, for once, simply enjoy the movies, games, books for whatever they are. It's not going to make a fucking difference if some of it is gotten over questionable ways. Second of all, pirating the game or pirating the movies is only going to hurt the studio that made them, and not necessarily the person that it originated from. So, just don't. It's pointless, it's unnecessary, and it's petty. Okay? Cool. Moving on. Public bool. Moving on. Zengran equals true. Nope. Is on ground equals false. You call it a golden retriever. Oh wait, not here. New function. I don't need the private, it is automatically private. Avoid on collision enter. Is on ground equals true. Okay. That should have updated it. Yep. Let's see if it works. Yep. Perfect. Just as it should work. Okay, Nags. Enjoy your lurks. I was doing it wrong because I was adding the in which case or whatever it is, if it's true or if it's false. I just need to invert it because it's if this is true and if this is true. So I need to instead invert it and be like, if this is not true. I'm thinking too straightforward. Alright, next.
Cool, so we've got our little character here in the forest, hopping along and
What was happening instead of what it should be, you were able to spam space and just fly into space. So with the if statement, it doesn't do that anymore. Or with the bool. So it checks if the player's on the ground or not. So while you're in the air, you can't press space again.
in the great outdoors. So happy to be outside, wild and free. Now, what we're going to do is we're going to add some obstacles to make this a little bit more game-like. So we're going to go into our assets folder, go to our obstacles. Let's go... kind of like this barrier. Kind of looks like a fence. So we'll go and drop this into our hierarchy. And we're just going to position this a little farther back. Let's put it at like the edge of the screen, like right there. Cool, perfect. So now that we have our barrier, you can see that it has nothing for components. So we're going to have to add some things like a box collider so that the player can collide with it. Cool, and we'll just resize this box collider really quick. So we've set up our box collider so that it looks really nice. Cool, that's perfect. Now we're actually going to add a rigid body. So now this is an actual physical object in the scene that the player can actually run into and collide with, and it'll use physics, so it might topple over if you run into it. If you notice, we actually didn't check the is trigger box on the box collider. That's because this isn't actually a collider that will have us destroy the object or anything. It's just so that we know when we run into it. And then we're just going to rename this barrier, this fence really quick, and we're going to call it obstacle. Now what we're going to do is in our assets folder, we're going to make a prefab because we're going to use this again. So we're going to make a prefabs folder.
Hi, Felix. I'll talk to you in a second.
And then we'll take our obstacle and we'll left click drag it down into prefabs. So now we'll make an original prefab. And here you can see that we have this fence saved. And now that we have this prefab saved, we're actually going to make it move in the scene. So we're going to make a script and we'll call it
Thank you for the
left.
follow. Much appreciated.
Name, because it'll just make things move left. So now we'll take the move left script, apply it to our obstacle, and then just make sure that we override our obstacle to apply to all of our prefabs. And then in our move left script, we're just going to open it up really quick. Now inside of our move left script, we're going to create a variable for speed. So this will just be private, and it'll be a float because we can always just edit it inside of our code later. We'll call it speed, and we'll set it to 30 for now. And then we're actually going to move this using our transform.translate once again, instead of trying to use physics to move a fence. So we'll just transform, translate like we always do. And then we're going to move it to the left since the fence is to the right of the player. So vector 3 dot left. We want this to move over time instead of moving every single frame. So we'll use time.delta time. And then we'll move it at the speed that we set. And then if we save, so now in Unity, when we press play, our fence flies at a really fast speed at the player, and I think it's just flying off in the distance. There it goes. Oh, there it goes. It's like it's haunted. So we can always change the speed of that to something less later. What we can do for now is, because we're actually making it look like the player is running, we're actually just going to move everything around the player to make it look like they're running. So if we actually take this move left script and we apply it to our background, this now creates the illusion when we press play that our player is running through the scene, even though in fact the player's not moving at all. You're going to make the player look like they're moving, so what you're going to do is grab an obstacle from the obstacles folder, create it, make sure that you add a box collider, a rigid body. If you want, you can even add the move left script now and add it to your scripts folder. And then you can create your prefabs folder, drag the obstacle down into prefabs.
Hell yeah,
And then
lies.
your move left script, you're going to give it a speed. So just set it for 30 for now. In your update method, you're just going to move it through translating the transform. So we're going to move it to the left over time at a certain speed. And then a nice little effect that you can do is on your background, you can actually add the move left script. So then that way when you press play, it looks like the player is moving to the right, when in fact everything else is moving to the left. Now it's your turn.
Alright. Hi, Faye! Also, hi, Felix, how are you doing? Thank you for stopping by. So, I actually don't want a fence. What else do we have? We have a barrel, we have several barrels, we have crates, we have boulders, there's stone walls. Ooh, we have tree logs. I like that. Let's use the tree logs. This needs to be a bit bigger. Let's make it 4. I'm probably gonna have to turn this. Actually, if I just pull it out more, you shouldn't see it too much clip into the ground. And if I just... yeah. Now you don't see it clip into the ground. Can probably even pull it back a touch. There we go. That should do. Yep. Doing school stuff at the moment? Nice. I forgot to turn my camera back on. Hi. Yeet the log! Yeet! Hey, I completely forgot what I was supposed to do. Medium obstacle position and when should we spawn? Play rigid body, box collider, edit collider, fit the obstacle, prefabs. Cool. Shush! Obstacle. Did I spell that right? Did I spell that right? Yes, yes I did. Okay. Lurking, getting food. Alright, Ghosty, enjoy your noms. Box collider and rigid body. I can freeze your positions. And then... Oh, perfect. I might make that a little lower. Just a touch. Okay. I might actually flip this the other way. Because I think this works better. Because you don't see it clip into the ground as much on this side. Yeah, I like this more. Because the other side can clip into the ground for all I care, because I can't see it on the side view here. I can see it a bit. It'll be okay. It'll be okay. Why am I showing you up? What did I do? I'm learning! I'm just learning! Oh, I see it. Shush! I highly doubt that. I highly doubt that I'm better at this than you are. Your prefabs folder, drag the original prefab in. I have just been following courses. That is all I've been doing. We can learn together. We can learn together and work on things together. I'm down too. I forgot to apply the script. With left. Apply the script. And prefabs. There we go. Pretty impressive. Happy you're not the only one using that, chat. I saw it and I was like, I'll probably stick in the background and stay quiet for a minute. And then I saw your ideas and I was like, that is actually really cool. I really like those ideas. I have a couple ideas. Well, your design documents are a lot more comprehensive than mine are. I will say that. Or at least they're a lot more in detail. Because my design documents are not necessarily that. Like, these are like my design documents. They're pretty short. They're pretty short and basic, just with a basic idea and nothing entirely thought out. I do have another design document from this one specific, like from the tutorial specifically, because they have like this project document loadout, which this is for the lab sessions, and it's gonna be like a Frogger type game, which we'll get there eventually. It's for, pretty sure there might even be a lab session here. Yeah, for each of these lab sessions, that's what it's gonna be for. But yeah, we'll get there, we'll get there. Yes, okay, now I just need to write the code. Move left. Cool. I need this to be private. Float. Speed equals 30. Float. And then transform. Translate. Vector 3 left times time delta time times speed. And that should make it move. Yeet. You're going the wrong direction! I just yeeted instead of unit. True though. Wait, you're supposed to be going towards negative eggs. Wait, why are you going to positive? The fuck? Why are you moving positive? That doesn't make sense. This is -1. Everything is right. Why are you going there? You are the one being stupid, Log, not me. You're moving in the wrong direction, because this is positive eggs. This is negative. What? The fuck? Did I touch something that I wasn't supposed to touch? Is it these? It shouldn't matter, I don't think. You're still going the wrong way. Oh, it's coming back. It's coming back. Maybe not. It might not be coming back. No, I don't think it's coming back. But what? Why? 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 You're supposed to go to negative, not positive. Oh, wait. I flipped it. That's the problem. I flipped it. So it does need to move right. I figured out the problem. It's because I flipped it. Yay. Okay, problem fixed. We're good. Problem identified and fixed. Tried to go to health for the one day and ended up doing the math wrong. Just had an ever-expanding greatboard go across my screen. Perfection. That's all I need to say. Perfection. I love it. Fuck. Let me handle your ticket real quick. Boop. Okay. I did everything? Yes, yes. Oh yeah, move the background. But I can't... How do I just needed to move locally. How can I tell it to do that in the script? Oh wait, isn't it just... Is it local transfer? No. There's a extra addition to that. There's the local vector, right? No. Let's see. No. Do I just flip the log back? Or do I make a separate script for it? I'll make a separate script for it. So I'll leave this one on left. And then I need a second one for the log. Move left. Obstacle. Yes, yes, yes. I know you angry at me. And make this right. There probably is a way to fix that easier, but I don't feel like fixing it. Remove this one. all. And then the background gets this one. And now everything should be moving, right? Yep, cool. Goodbye, background. Bye. Bye. Alright. That done and done. Spa manager. Boop, boop.
Alright, so we have it so that it looks like the player is running through the scene, when in fact everything is actually just flying at the player. So, now what we're going to do is we're actually going to use a spawn manager to be able to create more obstacles that fly at the player. So to do that, we're going to go into our hierarchy, and we can just right click and create empty. Now we have an empty game object, and this will be our spawn manager. And then in our scripts, we're going to make a spawn manager script. And then just make sure to click and drag that onto our spawn manager. So now that we know it's been added as a component, so we'll open our spawn manager up. So in our script, we're going to need a reference to our obstacle. So we need to make it public so that we can drop that reference in there. And since it's a prefab, we have to use a game object. And then we'll just call this obstacle prefab for now. And then close that. Now we're going to create another variable, very similar to a variable that we made before. So this will be private, so we can just set it whenever we want inside of our code. It'll be a vector3 because we're doing a position. And this will be the spawn position for our obstacles. And we'll set this to be a new vector3 since we're getting another position. And we'll set it to, let's call it 25 on the X so that it's all the way on the right side of the screen. We don't need it in the air, so 0 on the Y. And then we don't need any kind of depth towards us, so we'll call it 0 on the Z. And then in our start method, we're going to create that prefab once again using our instantiate method. So this way we can create clones or copies of our obstacle prefab. The object that we're going to create is our obstacle prefab, which we listed above. We're going to have it spawn at the position that we set in our variable. And we want it to be facing the same direction that we set it when we created this prefab. So get the obstacle prefab. We're going to get its transform component, and we'll get the rotation of our prefab. So you can see back in Unity, in our spawn manager script, it's updated to have that instantiate method. It's got our variables, so now when we press play, our obstacle should fly at us and we should create another one. I only see one obstacle. There goes our fence. Interesting. So at the bottom here it says that there was an unassigned reference exception. So this red exclamation point means that it was an error. And it says that our obstacle prefab wasn't assigned. Obstacle prefab of spawn manager. So I think actually what happened in our spawn manager, I see. So I didn't actually drag the obstacle prefab into the variable. So let me do that really quick. Cool. So now when I press
I'm definitely
play,
paying attention, not chatting
now,
on Discord.
Oh, there you go. So we have two. And I wonder if two are just going to fly at us randomly from the screen. Perfect. So since we're spawning one of our obstacles through code, we don't actually really need this obstacle anymore. That's just about everything it's going to do. and we're not editing a massive amount, so we'll just remove that. So then that way when we press play, it spawns one and it flies at us. Cool. So now what you're going to do is create your own empty game object in your project hierarchy, call it spawn manager. And then in your scripts, you're going to make a spawn manager script. You're going to add that as a component to the spawn manager game object in our scene. And then in our spawn manager script, you're going to make a variable to get the reference of our obstacle prefab. So it'll be public, so that way we can actually attach a prefab to it. It'll be a game object since it's a prefab. We're going to make a private position that we're going to spawn things at. So we're going to use the coordinates 25, 0, and 0. And then we're going to instantiate a new obstacle prefab at our spawn position and make sure that it spawns at the rotation that we had the prefab set up before. And then last but not least, don't do what I did and make sure to drag your obstacle prefab into the obstacle prefab section here in your spawn manager script. Now it's your turn.
All right. More of the same. Okay, so we need a spawn manager. Reset you. Then I need a spawn manager script. Add you to the spawn manager. Public game object prefab obstacle. And private spawn. Wait. No. Yes. I'm just being an idiot. Equals new vector 3. 25, 0, 0. Then instantiate prefab obstacle at spawn position and prefab transform rotate. There we go. This should spawn a new one. Yeah. And drag you in here. Yep. Oh, actually, I also have a different height though, right? Yeah. And a little bit out. Let me just copy these over as well. I'm probably gonna have to make this 1 and make this 3 or 4. What do you mean? Oh. Right. Who knows? Who knows? I forgot I needed to add the F. Okay, now it should spawn it at the right height. Yep. Cool. Bye, background. So I can get rid of you. And he'll spawn automatically now. Yeet. Hi, demon.
Cool, so now when we press play, our spawn manager spawns one of our obstacles, but we do need it to spawn more obstacles, so that way it's more like a game. So in our spawn manager script, we're going to set it so that we can actually create all of these obstacles at intervals again. So first what we're going to do is we're going to create another custom script so that we can spawn these obstacles. So we'll call this void spawn obstacle. Make sure you put parentheses, enter, create those curly brackets, and then we already have a line of code to create a new obstacle. So we're just going to take this entire line and we're going to cut it and paste it into spawn obstacle. Now we're going to reuse that method that we used before called invoke repeating. That's not in the right place at all. That's better. So invoke repeating we'll use to constantly call our spawn obstacle method over time. So we're going to use the name of our method, which is spawn obstacle. And we're going to give it a time to start at. So in this case, we'll just call this start delay so that we give our player a little bit of time. And then we're going to give it a rate that it's going to constantly repeat at. So we'll just call this repeat rate. And then our computer's mad at us because we actually haven't created those variables. So we'll do a private float for the start delay, since we know that 2 is generally a good number to start at. So we don't really need to change that one around. And then for the repeat rate, we'll just change this in code if we need to. So private float repeat rate, and we'll just have a repeat every 2 seconds as well. Now, if I go back into Unity, you can see that eventually we have these obstacles that spawn, and they fly very fast. Probably change that later. Oh, and then there our player goes. Now, one thing that you might notice, aside from all of the obstacles that are just flying away in the distance, is that at some point our player starts to lean over, and that looks kind of weird. A really cool thing that you can do, especially with rigid bodies, is you can see under all of these different options for our rigid body, there's actually constraints. So if we actually open up constraints,
Already ahead of you.
we don't actually want our player to be able to turn or move in any other direction except the Y. So we're actually going to just freeze the position of the X and the Z, as well as freeze the rotation of the X and the Z. And really, we actually only want the player to go up and down, so that's just the Y position, so we'll just freeze the rotation of the Y too. So now, whenever the player gets hit by an obstacle, they won't turn side to side, they'll just constantly only be able to move up or down. So if we press play, and then if I try and avoid these obstacles as best as I can, and I just jumped over that one, and so then let's see what happens if we run into one. Cool, and just get hit by the obstacle. Nothing happens other than that. I don't get
You jumped on top of it, you didn't jump over it.
So perfect, that's exactly what we're looking for. So now what you're gonna do is create your own variables
Suddenly,
inside
surprise
Spawn
cobots.
Manager for the start delay and the repeat rate. You're going to take your instantiate method from start, and you're going to create a new custom method called spawn obstacle. So then that way you can just call spawn obstacle whenever you need to create a new obstacle. And then we're going to reuse that invoke repeating method that we had before so that we can constantly call spawn obstacle, and it won't start until 2 seconds, and then it'll repeat every 2 seconds afterwards. And then last but not least, you're going to use rigid body constraints to actually freeze everything except the Y position, so that way the player can only move up or down whenever they jump. Now it's your turn.
Suddenly, pineapples. Alright. I can spell. Spawn obstacle. Wait. There we go. Take this into here. Hi Loki! How are you? Invoke repeating. Spawn obstacle. After start delay, every spawn rate. Come on, invasion plan, step 1. Attack nearby settlement with sticks and rocks. Come on, invasion plan, step 2. Run away, defeat and get Mama Dragon. Yes! Munch on lunch? Ooh, what'd you get for lunch? Private float. Start delay equals, make it 3. My spawn count, I literally have spawn rate written out. It was also supposed to be a float. And make this every 2. There we go. Curd crab salad and crackers. Interesting. Sounds interesting. Okay, this should be working. Let's see. Did I misspell something? I did. I did misspell something. Now it should work. Yes. Yeet. Yeet. And a yeet. And a tumble. Oh, you get left at home, so fair enough. Well, now the next problem is this. But I'm pretty sure we'll fix that in a second. Yes, now I can endlessly yeet logs. I actually want to move these back a bit more. Let's put them to 30. Okay. did that. Cool. And that's this lesson.
Cool. So we did some new things in this project. So we actually learned how to use getComponent as a method. So that way we could actually get the component of our rigid body for our player. We also learned some other things like using actual forces on our rigid body. So instead of moving things by transform translating, we move things by applying a force. So in our case, with the player, we can actually apply a force upwards. So that way the player can actually jump over each of the different obstacles. We learned a lot more about gravity and was able to change it using our gravity modifier. With our rigid body as well, we were able to freeze its constraints so that way the player was constrained to only moving in the Y position. In our player controller class, we made some more variables. We learned how to use the Boolean data type, which is used to store true or false. We learned a new operator, so multiply equals, so that way we can have physics gravity is set to the gravity times our gravity modifier. We also learned how to use new logical operators, like our two ampersand symbols, so that way we can see if the spacebar is down and the player is on the ground, then we do this line of code. In this line of code, we have the place where we add the force for our player to jump, as well as added an impulse force, so that force is applied immediately. And then finally, we used our colliders in new ways, instead of using triggers, to just detect collisions. With all that in mind, in our next lesson, we're going to fix that weird effect that we created, which made it look really cool, because it looks like we're running through the scene, but then the background just disappears, and then you can actually see that we're not running through anything at all. So, we'll see you in the next lesson.
Alright, neat. Next! Boop, boop, boop. Alright. Got the core mechanics of the game figured out. Player can tap spacebar to jump over incoming obstacles. However, the player appears to be running for the first few seconds, and then the background just disappears. In order to fix this, we need to repeat the background seamlessly to make it look like the world is rushing by. Also need the game to halt when the player collides with an obstacle, stopping the background from repeating and stopping the obstacle from respawning. Lastly, we must destroy any obstacle that get past the player. Yeah. Makes sense.
Being a programmer is a lot like...
Well, I'm sorry your Wi-Fi sucks, Loki. Hopefully it works at least semi, so you can at least watch a little bit, even if it's in lower quality.
being a magician. Since you control exactly what the user sees, you can do things behind the scenes to create amazing illusions. And that's exactly what we're going to do to make it look like the character is running through an endless world. What will actually happen behind the scenes in scene view is that the background object will move left, then reset, then move to the left again, and then reset. Endlessly, seamlessly, magically. By the end of this lesson, the background will scroll endlessly, but as soon as a player hits an obstacle, everything will stop. If you take a look at one of the backgrounds, you'll notice that it's actually two of the exact same image repeated twice. So what we'll do is get the width of one of those repeating sections, and as soon as the background has moved that distance, we'll reset it to its starting position. And the player will be none the wiser. As soon as we figure out how to get the background to repeat, we have to figure out how to make it stop when the player hits an obstacle. Here's the tricky part. The code that detects when the player hits an obstacle is in the player controller's script, and the code that controls the background is in the repeat background script. Somehow, the repeat background script needs to know when something happens in the player controller script. That way, when the player controller script detects when the player has run into the obstacle, the repeat background script can stop. We'll have to figure out how to make these two scripts talk to each other, how to communicate. We'll have to learn the ancient art of script communication. And to make all that happen, I'll see you in Unity.
I love how, like, lighthearted these courses are. They're just a delight. Oh, Fox happy noises? What is Fox happy about?
Okay, cool. So we have our little character here happily jumping along through the forest, and occasionally that obstacle comes through. But we do have a larger problem where, because we're making it look like the character's running through the woods, in fact, it's our background that's running away from our character. So we need to figure out a way that we can actually fix that. And I have a little bit of an idea. So one thing that I could do is actually, if I select our background and I Control D to duplicate, I can create another background, and then I can just keep creating these backgrounds over and over again, and then it'll just look like the player's running through. However, that's probably one of the worst ways that I could actually solve this problem, because then I'll just have maybe like 50 or 100 of these backgrounds that are just constantly moving all across the player, and eventually they do run out, so I can't actually make that infinite, and it'll actually create some big problems for making sure that our game plays well as it's trying to render all of these different scenes that are moving through the scene. So another option is if we delete this background, because I don't think that solution's a very good idea at all. Another way that we can think about this problem is we actually have this background here, and if you look at the halfway point, just about there, you can see that the background actually repeats itself. So it's got the same trees, then it's got the same rocks at the end. So we already have our own little repeating background, and actually we can think of the problem in this way, where if you take a look at the player screen, as we move the background over, just about at this point here, it looks like the background is exactly the same. And so what we can do is precisely at this point, we can actually just reset our background, and it will look like the player is constantly running through an endless background, when in fact it's just these two images next to each other, and we're just constantly putting it overlapping each other every single time we want it to look like the player's running. So we're going to try and do it that way instead. We're going to need a script in order to do so. So we're going to right-click on our scripts folder, create a C# script, and we'll call this repeat background in order to repeat our background. And now with this script, we're going to drag it and drop it onto our background object. And then we're going to make sure that it's applied. So now you're going to go into your scripts folder, make a repeat background script, and then you're going to apply that script onto the background. Now it's your turn.
Quick and simple. Close that. Then repeat background. And boop. Done. Next.
Cool, so we've taken our first steps in fixing this problem that we created for ourselves by making this background move to the left until it disappears. So we have our repeat background script, so we're going to go into that script by double-clicking. Now, in our repeat background script, we're going to create a variable for ourselves to make things a bit easier. So this will be a private variable, so we can just change it in our code if we need to later. It'll be a vector3 because we actually want the position. And in this case, we're actually going to be getting the position that our object starts at. Now, this will be very helpful so that we know where we should reset our background when it reaches the point that we need to put it back and make it look like it's repeating. Now what we're going to do is actually in our start method, we're going to set our start position And we're actually just going to get all of the coordinates of our transform position. And now we need to check to make sure that whenever we get to a certain position, we can reset our background to go back to our start position. So we're going to use an if statement to do that check. Now we're going to want to find the current position of our background. So we're going to use our transform position. And since our background is only moving on the x-axis, that's the only position we actually need to check against. Now we want to see whenever our current position becomes less than our starting position. But specifically, we want to make sure that our background is farther down the line on our x-axis before we reset the position of our background to be the starting position again. So we'll just use an offset for now, and we're just going to use like 40, I think. We'll see how that works. And then if we create a new line, and then we use the curly braces, in our if statement, we're going to set our transform position that it's currently at, and we're just going to reset it back to the position of our variable. Now in Unity, we'll see how this works and how this looks. So whenever our current position hits a certain point past the start position, it'll reset itself. So that looks kind of okay. It looks a little weird. It kind of looks like the background is stuttering in some ways. Let's see if we can fiddle with that number just a little bit more. Maybe we'll set it to like 50 so it's farther down the line. So we'll change the variable to 50.
It seems incredibly tedious, so I feel like he's gonna show a better way in a minute.
That looks. So now, hopefully our background can go a little bit farther down before it resets itself. And it looks a little bit better. It's getting almost there, but I think that's good enough for now. So what we'll do is, in your repeat background script, you're going to create your own variable for a coordinate. So you're going to use a vector 3, and that coordinate's going to be your start position of your object. In the start method, we're going to set the start position equal to the transform position, the current position of our object, just so that we always know exactly where our object started at when it was in the scene. And then we're going to check in our update function to see when our current position is less than our start position and a little offset. Then we'll reset the entire position of our object back to our start position. Now it's your turn.
Well, I'm just gonna assume he shows a better way. So, first of all, I need a new script. Oh, well, actually, I need to edit this script. Then private vector 3 start position. Then start position equals transform. If why are you like this? If transform position is smaller than start position, yeah, plus 50. No. Then, oh, I missed a dot. Then Transform position equals start position. Okay. And that should do that. The other way. Wait, but shouldn't it be smaller? Because it's moving to the... Because it's moving to the left. So it goes into negative. It's minus 50. My mistake. Now it'll move 50 and then I didn't save. No, I did save. I didn't save. Thank you. Not quite there. I mean, it's at 45, so if I set it to 45, it should do what it's supposed to do, right? So as soon as it's moved 45, right? Not quite. It's like a little bit past that. Alright, well, I'm pretty sure we'll get the fix in the next one.
Alright, so we've made it so that our background repeats every time it goes back through, but it does look a little bit weird. It's not exactly perfect. You can
Yeah, Demon, that's the point. That is the point. It is the full background thing. It is one image. It is one image of two separate images glued together effectively to make a parallax background.
definitely tell that something's wrong here, but at least our player jumps and they're still happy, so that's good. So in order to make our background transition seamlessly back and forth, we're going to use some new variables to be able to do so. But first what we want to do is we're actually going to use one of our box colliders to help us with this problem. So on our background, we're going to add a component, and then we're going to look for a box collider. And now you see that our box collider wraps entirely around our background, which is perfect, because once again, that means that there's less that I have to do myself to wrap that box collider. And you can see on our box collider in our inspector, it actually has a size. And that is extremely helpful because now we no longer need to guess what the halfway point is of our background. So now in
Felix, I 100% agree, and while I was fiddling around with it, I was thinking of having something chase the player or like get the player when they run into something. It's just like some player collides with something and suddenly everything goes to chaos. Everything goes to chaos. There's fire, there's chaos, there's explosions. So we'll see about that.
our repeat background script, we're going to use another variable, and this one will be private since we know exactly what we need now. And it'll be a float since you saw the size had some decimals in there. And we're just going to call it the repeat width. And so this will be the width that we actually repeat at when we want to reset our position. In our start method, we're actually going to set our repeat width. So we'll use repeat width. And we're going to set this to the size of our box collider. Now, because our box collider is a component, we're actually going to need that get component method again. So we're going to get component. And now we need that left and right caret so that we can get the type of component we're looking for. So in this case, we're looking for a box collider. And then we're going to use our parentheses since this is a method. So now we're getting the box collider on our object. And what we want to do is we can actually get the size property of that component. So if we type in size, and then we get the actual X size, so then we can get the total width of our background. And we're just looking for that exact halfway point. So we'll divide using one right forward slash by 2. And that'll give us half the size, half the width of our background. And then
What do we need the box collider for? Can't you just divide, like, can't you just have the actual... Oh, because there's no size in the sprite file. Okay, never mind, I'm stupid.
last but not least, the only thing we need to do is get rid of this hard-coded number right here. And this will be our repeat width. So now, when we save, now that we're back in Unity, you can watch as our happy little player runs through the scene, and it looks like, even though you can see the scene moving back and forth in order to make it look like it's repeating, in the player's view, it looks exactly perfect. So, now it's your turn. So, what you're going to do is you're going to apply a box collider on your background, and then in our repeat background script, you're going to create another variable, a private float called repeat width. You're going to get your component of your box collider in the start method, and you're going to get its specific size and only on the x-axis. And then you're going to divide by 2, so that way you can get the exact halfway point of our background. And then you're going to change your hard-coded number to be repeat width. Now it's your turn.
Yeah, okay, makes sense. Got it. Will do. First of all, box collider. Box collider. Perfect. And then private float repeat width, and set this equals good component box collider size x divided by 2 and change this number. Right. And now you will do what I want you to do. It is very fascinating that you can't even see a jitter. You can't even see a jitter in the background. This feels like a lie. It is a lie, and it feels like a lie. Well then. Make a game about kobolds, I swear. I mean, go for it, by all means. Please. Should I... Let me put one here real quick. Should I just, like, move this actually to be above ground? So it tumbles, or should I leave it in the ground? I'll leave it in the ground. I can't be bothered to fix this. Cool. Yep. Next. I need a cobalt model, Felix, then I can add them.
Really good now. So we have the background that scrolls endlessly. We have our happy player who jumps through the forest as they're avoiding all these obstacles. And now what we want to do is we want to actually make it so that we can end our game and send it to a game over screen. So what we're going to do is we need to figure out how we can actually label all of these different objects so that whenever our player collides with them, we know what we've hit. One really cool way of doing this is by using something called tags. So if you look at the top right of our inspector, we have our ground selected, and there's this little button called tag. And what we can actually do is create different tags for different things. So we could actually go and tag our player as player, tag our main camera as our main camera. We can tag locations, different things like that. So we'll actually create our own tag by clicking add tag under that drop down. And you'll see that there's a tag here that says list is empty. So this is our list of tags that we can use that we created. We haven't made any yet, so we'll actually go to this little plus sign on the bottom right of this bar. And we'll click that and we'll add our own tag. So we'll call this one ground. And then we can press enter to save. And now when we go back to our ground, oh, that's weird. So what you actually have to do is you go to the tags in your inspector, you click the drop down, and it brings up all the different tags, and then you select the tag that you want to use. So it doesn't, unfortunately, automatically tag something when you create the tag, so you just have to make sure you go back into whatever you want to tag and apply the appropriate one. We're going to do the same thing to our obstacles, but in this case, since we have prefabs, we need to double click on our obstacles or click on the obstacle and click open prefab. And then you can see we have another tag here, so we'll go to click it and it's untagged right now, so we'll add a tag. And we already have our ground tag, but we want a new tag, so we'll create another one and we'll call this one obstacle. Now if we go back to our hierarchy that shows us our prefab preview, you can see the obstacle here, so if we click that, and then under tags, just make sure that you go and tag it obstacle. And then when we leave our prefab editor, by using the arrow next to the obstacle underneath our hierarchy, now whenever we create obstacles, it'll have this tag applied to it that says obstacle. So now we need an actual way to interact with these obstacles. So we're actually just going to use our player controller script. And then in our player controller script, you can see that we actually already have a way to detect collisions. In this case, we're detecting a collision on the ground. So in our player controller class, this is actually where we'll just store the state of our game over. So we'll just make a public Boolean for now. So that way we can see when our Boolean is true or false. And we'll name this game over. So now we have our game over state saved, and we're actually going down, and you can see that we conveniently already have a way to track collisions against other things using our onCollisionEnter method. So this is actually the place where we can compare the different tags whenever we run into those objects specifically. So we'll start actually with the ground since we already have this variable here. So if, and then our condition, we're going to use collision, because in this case, the collision is actually the object that we're colliding with. And then we're going to call that collision's game object. And on that game object, we can compare the current tag that it has. And we can actually use a string for that tag, so we named our ground ground. Now, in our statement, we can specifically check when we collide with a certain game object. We can check that game object's tag and see if it's ground. So now we'll take our isOnGround variable, and this is where we set it to true. And now, after we've compared for the collision of the ground, we can actually compare for the collision of our obstacle. So we'll actually use an else statement. So else, if what we're colliding with is an obstacle, then we'll do this thing. So we'll check first if we're colliding with the ground. Otherwise, if what we're colliding with is an obstacle, we'll do this. So we can use a debug.log statement so that we can see in the editor in Unity when our game is over. And then we have that handy game over Boolean at the top. So since its default value is false, now we set game over to true. So when we go back into Unity, when we play our game, you should see on the bottom left that game over pops up and tells us that we ran into an obstacle. So we'll just wait for one of these fun obstacles, and there's one. Ooh, missed it. My farmer's just so excited. And then we'll hit this one, and boom, you can see there's a game over at the bottom. So now what you're going to do is you're going to make sure on your ground that you add a ground tag by using the drop down, adding a tag, and then in this list creating a new tag. And then what you're going to do is you're going to go into your obstacle prefab, and then you're going to apply a tag to this as well called obstacle, and then just make sure that you apply the tag before you leave the prefab editor. And then in your player controller script, you're going to create a game over variable so that we know when the game is over or when it is not. And then we're going to change some of our code in our onCollisionEnter method so that we have an if statement to see if the object that we collide with is tagged as ground. Then we can set isOnGround to true. Otherwise, if the object we collide with is an obstacle, then we set our game over to true, and we tell our editor in Unity that the game is now over. Now it's your turn.
All right. So we need 2 tags. Ground and obstacle. You get the ground. You get the obstacle. Player controller. If collision game object tag is ground. Put that there. Else if collision game object compare tag is obstacle. Public. Oops. Cool. Game over. I just like setting it because I know what it is then. Debug log. Game over equals true. Boop. Yep. Works perfectly. Boing. 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 Alright. Let's see how this works.
Cool, so we have our character in the scene, and whenever we run into one of the obstacles, but right now he's so happy we just missed one, and we hit one of them, and you can see game over pops up at the bottom. Now, we actually want to be able to do things when we end our game. So one of the things that we'll do is we'll make it so that the background stops scrolling, and the obstacles stop when the game is over. To do that, we'll actually need to do some communications between our scripts to be able to know when to stop the game. Now, in our move left script, how exactly are we going to know what's happening in our player controller script? Well, for now we'll create a variable so that we can hold a reference to our script. So specifically because our player controller script is a class called player controller, we actually just call player controller. Now this is very similar to how you would just call game objects, but in this case we're just calling a player controller. And we'll name this player controller script, and although not very creative, is very descriptive, which is incredibly helpful. Now in our start method, this is actually how we're going to connect our reference to our script to the actual player controller script in our game. So we're going to use our player controller script, and we're going to set this to the player controller script on our player. So we can actually use the game object class, and in our game we're going to find the name of our object, which in this case in our game is called player. So this will find player in the scene hierarchy. And now that we've found our player, we can actually get their component. And we're looking for specifically their player controller object, which we put inside the left and right carets. And then since this is a method, we make sure that we put our parentheses. So now this is how we can set our player controller script to be the actual player controller script in our game by using the player in our scene. And now in our update method, we can actually stop things from moving whenever we collide with that player and the game over condition happens. So if player controller script, since we now have that reference, and we want to check whenever the game is over. However, In this case, we're looking to move things when the game is not over, so if game over is equal to false, we use those two equal signs to say that it's equal to, instead of setting game over to false. And then we use our curly brackets, and then press enter, and we can actually just cut this entire translate method and put it inside this if statement. One very important thing to note is that you can see that we can very easily get our game over variable from our player controller script. Now, if this was a private variable, in fact, we wouldn't be able to see this at all. Now, if game over were a private variable, we wouldn't be able to see this at all. Just like public variables can be seen in the Unity editor and private variables cannot, public variables can be seen in other classes while private variables cannot. So if I were to get a move left script somewhere and I wanted to get the speed variable, I would have no way of doing that. If I made the game over variable private inside of our player controller script, I would have no way of seeing this variable and being able to know if it was true or false. So now, if our game over is false, if our game is not over, then we're just going to keep moving things to the left. So if we save in Unity, now this time, when we play the game and our player runs into one of the obstacles, everything stops. And we're still jumping for joy, so excited. And you can see all of these obstacles just spawning on each other, and there's not enough space. Now what you're going to do is in your move left script, you're going to get a reference of our player controller script on our player by creating your own player controller variable. In our start method, you're going to set that variable to the player controller object or component on our player game object in our scene. And then whenever the game is not over, we're going to make sure that all of our obstacles and our background keeps moving until our game over happens. Now it's your turn.
If I'm not mistaken, there's an easier way to do this. Let me see if I can figure this out. Because you don't need to assign it to a variable. I don't believe you do. Pretty sure there's an easier way. No? I've used Or are they gonna flip and move the other way? Nope, they do work. I believe they're turned the wrong way now. Right? If I set this to 0. Well, yes, it does work. In which case, though, they still have the right one. Because it doesn't start with a basic rotation anymore. How can I move this with the same script? There is a local thing for this, but I don't remember it. Because yeah, on the local, this is the way it's supposed to be. Also, I just realized I forgot to turn my camera back on. Move relative to object's rotation.
Suddenly you're nowhere to be found. I turn around and everything has changed. Looking for a way to work it out. I'm trying to find some peace to navigate. The oak tree where I met you and the writing on the statue. I still remember every word you said. I'm not a soldier, but I'm fighting. Can you hear me through the silence? I won't give up 'cause there will be a day we'll meet again.
So transform direction. Well, let's see if we can make this work.
We wanted turned to gold.
Because I can still use the proper rotation then.
Future on our side.
Game object, no.
This on my own.
What do I call it? Prefab.
I will get so left behind.
Prefab, obstacle, transform, rotation.
I still remember every word you said.
And if I then...
Can you hear me through the silence? I won't give up 'cause
I already forgot the thing.
we'll meet again.
Transform direction from local space to world space. Yeah.
Dark for the sunrise,
Right.
clouds for a blue sky, space for the traveling star. Strong from the inside, you're still my lifeline. I feel you wherever you are.
Is that the correct one?
The oak tree where I met you and the writing on the statue. I still remember every word you said. I'm not a soldier, but I'm fighting. Can you hear me through the silence? I won't give up 'cause there will be a day
let's just see what this does. And see if it helps. Oh wait, I can just... I'm gonna just turn that script off for now. And this one underneath it. So let's see what happens. Nope. Vector 3 direction. Well, I would still have to turn it then, wouldn't I? Because this would just flip the background the other way then. Right? No? It also doesn't fix the log though. Alright, fuck it, I have no idea. So I'm just gonna add the same thing to the other script. That's what I get. Alright. Copy this into this. Yes, yes, shush. I know you have no reference. I just realized I didn't save that. Wait. If I didn't save that yet, was it actually fixed? Hold on. Was it actually fixed and I'm just an idiot? Transform direction. Was it fixed? Wasn't fixed and I'm just stupid. No. No, it was not. Well. Back to what I was doing. Save that for now. Maybe, but keep positive here. Shush. Alright, put this here, and then put this up top. There is definitely an easier way to do this, but I can't be bothered to figure it out right now. So, this should be working now. So if I dooch, excusez-moi. Oh, because I copied this. This is supposed to be right. I don't fucking know, don't ask me. There we go. Nice. Boing, 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 boing. Alright. That's working, that's working, that's working. Cool. Yep, 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 yep. Cool. I didn't forget anything. Next.
Cool, so we have all the right steps to make our game end. So when we hit one of the obstacles coming into the scene, everything stops. However, you can see this problem where we just have this infinite number of obstacles being created non-stop. Let's see how many we can pile on. I don't actually want to see that, so what we're going to do is we're going to fix that small problem just because we don't want to keep creating all these obstacles in the scene. We just want it to stop entirely, so that way our game doesn't just slow down to a standstill because there's 1,000 of these little obstacles all the way over here that you can't see. So we're going to go to our
It'll eventually
spawn
creep
manager
its way
script,
to the screen.
and using the same thing that we just did in our move left script, we're just going to get another reference to our player controller script.
Sorry.
So if we make another private player controller, and we'll call this player controller script. Now in our start method, we're going to attach our variable to the reference of our player controller script in the scene. So we player controller script, we're going to set that to a game object that we're going to find in our scene, which happens to be called player. And then in player, we're going to find the component, which is our player controller. Now, in order to stop spawning our obstacles, now that we have a reference to our player, we're actually going to check for when the game's over inside of our spawn obstacle method. So if we use an if statement, if our player controller script game over boolean is false, then we can just cut this little bit out and paste it in our if statement. So now when our game over is false, it'll keep creating all of these objects. However, when our game is over, then it stops creating these objects. Now, if we save that and we double check in Unity, you can see that our player hits our obstacle and none of the obstacles are magically spawning, which is great. So now it's your turn. In your spawn manager script, you're going to create another player controller variable. In the start method, you're going to set the player controller script variable to the player controller script of our player object,
AKA copy
scene.
and paste.
And then to stop spawning any of these obstacles, in our spawn obstacle method, we're actually going to check when the game is not over to keep creating these obstacles. Otherwise, when the game is over, it'll skip over this line of code and it won't create any more obstacles. Now it's your turn.
AKA copy and paste. Boop. Boop. And a boop. And boop. And then if player controller script game over equals false. Unity or C# fuck you. There we go.
Try to keep the hand just in case I miss you. Please wake me with a kiss. Would you wake me with a kiss? Would you wake me with a da 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 dum da 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 dum da da dum da da dum dum da da dum
Oh.
da da dum.
Saw nothing. There we go. Why are you still spawning them? You should have stopped. Because it took the wrong one. That's why. This is why you read your code properly and don't just hit autocomplete on everything. Why are you not spawning now? Good night, demon! I do not understand. What is wrong? Game object, find player, get component, player controller script. No, I had it right. God damn it. Flaws, yes. Fucking hell. Because I had the wrong thing written out completely. Now it should be spawning. You can tell I've been doing this for too long. You forgot Surf Rock can be sad. Now you remember? Surf Rock? Alright. We also won't be going for too much longer.
So we're almost there with the mechanics of our project, but we do have one last small problem to deal with, which is whenever we jump over one of our obstacles, you can see that they just fly off into the distance forever, and so we actually need to get rid of them because otherwise they'll just keep creating obstacles, and then it might slow our game down. To do that, we're going to go into our move left script, and now in our move left script is a good place where we can keep track of our obstacle and then remove it from the screen whenever it goes off the player's view. So in our update method, we're going to use another if statement, and we're going to get our current object's transform, position, X. So that way we can see when the position goes past the edge of what we can see. And for now, we're just going to set it to something like -10, and we'll just see, and if that works, then we can turn it into a variable. And then we'll write the thing that we want it to do when this happens. So, when our object goes past -10, we're going to destroy our game object. Perfect. Now, let's see how this works. So now, if we watch our obstacles in our scene, we should see them get removed whenever they go past the end. Uh-oh, I broke something. On the upside, the obstacles delete at just about the right place. Maybe we'll set it to like -15. Let's see, what did we do wrong? I see, so we didn't use that tag system that we had set up, and so it's just deleting anything that goes past this point.
Well, I don't need to, because I have two separate scripts.
The background went past -10, it deleted itself. Not that big of a problem, so we'll just make sure we take the current game object, and we'll just get the tag that's on it, and we'll make sure that it's an obstacle. And then we have this -10, so we're just going to make this the left bound, since this is the left boundary of what we're hitting. And then our computer's mad at us because this doesn't actually exist yet, so we'll make this variable. Since we already know the number that we want to set it to, so we'll make it a private float left bound. And we'll just set this to -15. And so now when we save,
Fair.
and then we go back into
That works.
Unity, when we play, hopefully our background doesn't delete itself. Cool, so our background's still going, and we have the obstacles delete themselves, so perfect. Now we have all of the mechanics that we need. So now what you're going to do is, in your move left script, you're going to create your own variable for the left boundary. And we're going to go into our update method and create a new if statement. So we're going to compare our game object's current position to see when it goes past the left boundary on the left side, and make sure that it's an obstacle instead of just deleting our background as well. So when it's both past the left side of our screen and the thing that's moving is an obstacle, then we'll destroy that game object. Now it's your turn.
Well, the thing is, I have two separate scripts because my obstacles are actually moving in the right direction. So I suppose I don't need to do the tag. So yay me. So, no. If transform position is smaller, because it's going negative. Smaller than left bound. Then destroy game object, and then set private float left bound equals -15, and that should do. Well, I should probably jump over them if I actually want to see them get deleted. Steam, go away. Yep, works. Cool. Perfect. I'm not gonna bother with comments right now. That's probably something I do after, if I get back to this code.
Cool, so to wrap up everything that we did in this lesson, which was a lot, we basically finished all the functionality of our game. So we have the endlessly scrolling background that always repeats itself, and then we have the player jumping, and when they hit one of the obstacles, it ends our game with a game over. And then we fixed that little bug that's constantly spawning all of these obstacles back here, as well as keeping track of all of the obstacles that fell off. So now we can keep our game running as efficiently as possible. On top of that, we used a repeat background script to be able to get the width of a box collider that we applied to our background, so that way, whenever the background goes past a certain position, it'll just reset itself and make it look like it's endlessly scrolling. In addition, we learned how to get references of other scripts in our scene, as well as figured out how we can find those scripts so that we can actually use the variables in that script to be able to control the state of our game using if statements. We also learned about a new operator that we can use, two equal signs, otherwise known as equality operators, which will help us to check if something is equal to something else. In this case, if our game over is equal to false. And then finally, we learned how to use tags in our scene so that we can compare tags to only do things when we have certain game objects that we're interacting with. Now, in our next lesson, our character here looks extremely happy on the inside, but on the outside looks very rigid. So we're gonna do some work with animations. See you there.
Yay! He's happy on the inside, but a husk on the outside. Just a dead shell. Oh boy. Reports from the front. Furry scoundrel jumped on your windowsill, pushed their head against your window, and jumped off in the darkness of the night. Well... Alright. What time is it? It's 9:30. I kind of don't want to end stream just yet. But I also want to keep doing this, but I should take a break. Actually, no, you know what? We're gonna go and call it here. So, we're gonna go and end stream, and I will probably keep working on this afterwards in the background. So, we are gonna go rate nobody apparently, because nobody's live. Well, then I guess we're just gonna call it here. So, I thank you all so much for watching. For those that are new here and haven't followed yet, School Nights for to return so I can track down its witch. But yeah, for those all that are new here and are just lurking, feel free to follow. Follower alerts are anonymous, so you don't have to be worried about being called out. You can continue your lurk as normal. Otherwise, if you want to stay updated with everything, make sure to join the Discord server. It keeps you updated with everything I do, as well as I will announce when I cancel streams or move a stream. Yeah, I won't overwork myself, don't worry. That's specifically why I'm taking a break. And lastly, make sure to check out the YouTube channel. This VOD will be going up 24 hours after the end of this stream. Actually, probably longer than that, because I usually upload them just at 12, because it's easier to keep track of. And yeah. I will see you guys tomorrow. Actually, we don't even need the rate message. I don't know why I tapped that. Yeah, I'll see you guys tomorrow. Until then, have a good night. Bye bye!